Okay, lesson 25 is on the dot product of vectors and the angle between two vectors. This kind of continues our conversation about vectors. It actually completes our little sections on vectors, so we don't have much more with this. So it says vectors can be multiplied in different ways. So one way, which is called the cross product, is used when three dimensions are utilized, and it creates a vector that is perpendicular to both vectors. So if you talk about the cross product of vectors, you can kind of see what it is geometrically, because you can kind of think of the corner of a room. So there's three vectors, and they're all perpendicular to each other. Okay, so the cross product actually helps you find perpendicular, or we use the word normal vectors, right? So luckily for you, we're not going to do cross products, but we are going to do another type of product, which is super simple. So we're going to be discussing something called the dot product. And what this does is it creates a scalar, which is a number. And this number seems completely useless at first. Like, there's no like geometric representation of it, so it doesn't create like a perpendicular vector or anything really like that you can see on a picture. Okay. However, I can assure you that it is used a great deal, and like I said, it's super simple. Okay, so if I have two vectors, u and v, now remember you can see vectors with the arrow over them, or you might see a bolded u. So if you see u dot v, then what we do is we multiply our, I'll call them the x components, right? The first numbers together, so u1 times v1, and then I add it to u2 times v2. Okay, so like I said, very, very simple. So in example number 1, I have 4, 5, and I have -1, 3. So what I'm going to do is I'm going to do the 4 times the -1, and I'm going to add it to the 5 times the 3. So I get -4 plus 15, which creates the number 11. So 11 is the dot product of those two numbers, of those two vectors. All right, so the next one, I'm going to have -6 plus -6, so I end up getting -12. So I just took the two x components, multiplied them together, took those, multiplied them together, and then I added and got -12. Okay, it might be a little more difficult when you see it in the ij form. So if you want to write it like 2 comma -3, and then multiplied, write the dot product with 5i and 0j, so 5, 0. Then we're going to have 2 times 5 added to -3 times 0. So our dot product is 10. Okay, so how do we use the dot product? One of the most important ways of using the dot product is to find the angle between two vectors. So it says if theta is the angle between the non-zero vectors u and v, then cosine of theta ends up being u dot v all over the magnitude of u times the magnitude of v. So if you remember, the magnitude is just the length, right? And we found that in the last section by doing x squared plus y squared, or u1 squared plus u2 squared if you want to. All right, so that means that theta, if you solve for theta, you get inverse cosine of u dot v all over magnitude of u, magnitude of v. Okay, the formula that I typically remember is this one. I don't usually write the inverse cosine one. Okay, so you're going to memorize that one. So number 1, it says find the angle between the two vectors in degrees, round to 3 decimal places if needed. Okay, so what we have is cosine of theta equals u dot v. So I'm going to have 2 times -1 plus 4 times 3. Then I'm going to have the magnitude of u, so 2 squared plus 4 squared, and the magnitude of v, so -1 squared plus 3 squared. So when I work this out, I end up getting, let's see, -2 plus 12, so I get 10, square root of 20, and square root of 10, so square root of 200. And if you rationalize this, you actually get 1 over root 2, which is root 2 over 2. So we want cosine of theta is equal to root 2 over 2. Now you could probably do this without a calculator, but if you need your calculator, that's fine. So you're going to do inverse cosine of root 2 over 2, and you'll end up getting theta is equal to 45 degrees. So make sure you're in degree mode since I asked for degrees. And you can kind of check if you were sketching out these vectors, you have 2 comma 4, and you have -1 comma 3, and yeah, 45 degrees makes sense for that angle. Okay, if it looks like an obtuse angle and you're getting 45 degrees, maybe it's not right, right? But luckily, if you do this formula, there's never going to be one of those situations where you have to like add 180 or anything like that. It's always an angle between 0 and 180 degrees. Okay. So the next one. So let's look at it in the vector form. So 2, 1, and -1, -3, like that. So we're going to do cosine of theta equals u dot v, so -2 plus -3, all over magnitude of u, magnitude of v. So if I do 2 squared plus 1 squared, I get 5. 1 squared plus 9 is 10. So I end up getting -5 over root 50, which is also root 2 over 2, but now it's negative. So when I find theta, I do my inverse cosine again, and this time I get 135 degrees. Okay, so the angle between those two vectors was 135 degrees. All right, so number 2 is probably the most difficult question that you'll have in this section. And I think you do have one of these on your homework. I did not put several of them, no worries. But it says find the vectors v satisfying u dot v equals 10, u is 2, 3, and magnitude squared of v is equal to 17. Okay, so what this ends up being is a system of equations. So we're going to have to use substitution or elimination to find the components for v. Okay, so basically u is some vector u1, v1, or not u1, v1, u1, u2. And v is some vector that's v1, v2. Okay, so when I say u dot v equals 10, what I'm saying is that u1 times v1 plus u2 times v2 has to equal 10. But luckily I know u is 2, 3. So what I really have is 2v1 plus 3v2 equals 10. Okay, so I at least know u. But then I know that the magnitude of v squared, so think magnitude's under a square root, right? So it's like v1 squared plus v2 squared under a square root, but now we're squaring it. That equals 17. So this is not a very simple system of equations because we have these two equations and one of them involves squares. Okay, so it's not like you can line them up and just do your elimination method, right? We can't do that. So we have to do the substitution method. So what I'm going to do is I'm going to solve one of the equations for either v1 or v2. Okay, so let's say I solve this first equation for v1. When I do that, I'm going to have 10 minus 3v2 divided by 2. And now I'm going to substitute it in for this v1. Okay, so it's going to get momentarily a bit messy. So I'm going to have 10 minus 3v2 over 2, everything squared, plus v2 squared equals 17. And I'm going to FOIL it out. So when I FOIL this all out, I get 100 minus 60v2 plus 9v squared all over 4 plus v2 squared equals 17. And I don't like that 4. So I'm going to multiply both sides of my equation by 4. So now I get 100 minus 60v squared, or v, not v squared, v sub 2 plus 9v sub 2 plus 4v sub 2 squared equals 17 times 4, which is 68. And I get everything on one side. Okay, so when I get everything on one side, I have 4v2 squared plus, minus 51, is that right, 60, did I forget a squared? I did forget a squared. Oh, so lucky I caught that. I could have gone this whole time. It would not have been fun. All right, so I have 13v2 squared minus 60 v sub 2 plus, I believe it's 32, equals 0. And you could try to factor, or you could use quadratic formula. So I personally thought that the numbers were big, so I used quadratic formula. It does factor out. So if you want to do that, go for it. But basically, when you either, so you do factoring or the quadratic formula, you get v2 is equal to 4, but it could also be 8 over 13. Okay, so then we want to find v, and v is two components, right? So one of them has 4, and one of them has 8 over 13 for v2. Well, we still need to find v1. So what do? We go back to where we have this equation and we plug in. So if v2 is equal to 4, then v1 is going to be 10 times 3 times 4 over 2. So I get -1. And for the other one, v1 would be 10 minus 3 times 8 over 13 all over 2. And for that one, it ends up being 53 over 13. Okay, so we get -1 and 53 over 13. But both of these are my solutions. So yes, the -1 and 4 looks very, very nice. You could probably even guess that one using guess and check. But you probably couldn't use guess and check to get the 53 over 13 and the 8 over 13. Okay, so guess and check is not the best method for these problems. All right, so like I said, that one's probably the hardest one that you will have on your homework. The rest of them are pretty simple. All right, so it says if the vectors u and v are perpendicular, then the angle between them is 90 degrees. This means that our formula, right, if theta is equal to 90 degrees, is cosine of 90 degrees equals u dot v all over the magnitude of u times the magnitude of v. But we know that cosine of 90 degrees, right, if you think about your unit circle, that's the point 0, 1. So cosine of 90 degrees is 0. So in other words, 0 is equal to that whole quotient, u dot v over the magnitudes. But if 0 equals a fraction, like something over something else, right, it has to be the numerator. So what we know from that is that if our vectors are perpendicular, then 0 equals u dot v. So if u dot v is equal to 0, then our vectors are perpendicular to each other. So you might hear the word orthogonal, or you might hear normal. All of those mean the same thing. Okay, so it says prove that u and v are orthogonal. Okay, so if we're proving that they're orthogonal, then we're going to have 4 times -3 plus 6 times 2. So I'm doing the dot product. Maybe I should write. So I get -12 plus 12. So I get 0. So yes, that means that they are perpendicular or orthogonal. Okay, so this one says find a vector that would be orthogonal to -4, 13. Okay, and you guys are probably very good at this. So we want to think about this getting to be 0. So we're probably going to have some kind of combination of 13 and 4. So let's think about it. If I do -4 times 13 plus 13 times 4, does that get me 0? Yep, sure does. So it's +13 and +4. But that's not the only one. Okay, so you can check, and you could try other things, like maybe I multiply by 2, and I have 26 and 8, right? That still works. So any multiple of this, so if I have any like number out front and I multiply it in, even like 1/5, right? If I take -4, 13, and I have 26 over 5 and then 8 over 5, that still works out. Okay, those are still orthogonal. Because basically all we're doing is we have the same vector. So if I sketch it out, I have -4, 13. Let's do 13 here. That's my original vector. And 13, 4 is here, and they are perpendicular to each other. But what about these other ones? Well, if I have 26, 8, it's still the same line. Okay, it's just a lot longer. And maybe I have one that's a little bit shorter, right? That's still orthogonal. So it's still the same direction, it's just their lengths are different when you're multiplying by a scalar. So yes, there are an infinite number of answers. All right, you might also see something about u dot v being parallel to each other. Okay, if they're going to be parallel to each other, that means that cosine, instead of having 90, it was equal to either 180 or 0, and that would give parallel. Okay, so basically if you have u dot v is equal to, so like think about these being here, 1 or -1, then you would get parallel.